All right, you guys. Hi, this is Mrs. All Day. We are working on our last lesson for the 2-week span of the pacing guide. So we are on 7-2. This is day 9, Algebra 2 General, Child's High School Remote Online Learning. We are going to do continuously compounded interest. All right, so this is the sheet you should have. Yesterday we did page 1 and page 2. And today we're just doing page 3, so this will probably be the shortest lesson we have. There's a couple of things that I need you to do. So first of all, at the very top of the page, I'm going to give you a formula. All right? A of t, make sure you write this down, equals P, which stands for the principal, times 1 plus the interest rate over N, which is the number of times that the interest is compounded per year, close your parentheses, to the N times T. All right, first of all, you need to know that P stands for principal. Now, what we're talking about here is we're talking about if you put money in a savings account and the interest is compounded annually or semi-annually or quarterly. That means it's compounded so many times a year. If it's done annually, it's once a year. If it's done semi-annually, it's twice a year. If it's done quarterly, it's 4 times a year. So, compound interest is interest earned on the initial amount and on the interest you've already earned. So, like, let's say you put money in the bank and it earns interest after 3 months. You have that money that you put in the bank plus the interest. And then in 3 more months, it earns more interest. So you're putting more money on top of what you already had. So this is called compounded interest, where it's continuously being compounded. All right, so let's just talk about this formula, which is very important that you need to look at it and understand it. Now, A of t is going to be the amount that you have in your savings account after the interest has been compounded. Okay, so that's your amount you're looking for after so much time. P is the principal. That's what you put into the savings account. All right, this is the rate over the number of times it's compounded a year. So if it's semi-annually, it's going to be a 2. If it's quarterly, it's going to be a 4. If it's only annually, it's going to be a 1. And then you're going to again use that N, you're going to use it again on the outside with your exponent. That's an exponent. You're going to take however many times they compound your interest in times how many years. Are you looking at 1 year down the road? Are you looking at 5 years down the road? Are you looking at 6 years down the road? So T is always going to be the years. N is going to be the number of times each year or per year. Sorry about that. My laptop fell. But it didn't break. It just slid back. All right, so let's look at this first one. Put a star by it. That's where I'm at. If you put $10,000 in a savings account, okay, first of all, that's your principal amount. You're putting $10,000 in the savings account. Always dissect as you go. And it earns 4% annual interest. All right, so your rate is going to be 4%. And remember, we dropped the percent sign and moved the decimal 2 places to the left. So that's 0.04. That's what we'll use for the rate. 4% annual interest that's compounded semi-annually. Okay, that's what your N represents. Remember, that's the number of times a year. Number of times per year. And for this problem, it's going to be 2. How much money would you have at the end of the year? Okay, that's your A of t. Okay, that's how much money you're going to have. All right, so we're going to use this formula that we just wrote down. I'm going to erase a lot of this scribbling. It's not really scribbling, I'm just kidding. But I need to focus. I need to see some stuff. All right, so let's do it with blue. So we're going to have A of t equals P times 1 plus R over N to the N times T. Now I'm writing it because the more you write it, the more you'll get it. Now, how many years are we doing this? How much money would you have at the end of 1 year? So our T is going to be 1. So A of 1 equals the principal amount, which is 10,000, times 1 plus the rate, which is 0.04, over N, the number of times per year, which is 2, raised to the N, which is 2, times T, which is 1. So I'm just going to put a 2 there. But we multiplied the 2 times the 1 to get the 2. All right? So you need to do what's inside the parentheses first. You can't add the 1 to 0.04 divided by 2. You have to go ahead and do the 0.04 divided by 2. So I'm going to pull up my calculator, and that's what we're going to do. So you can pull up yours or you can use your own. Okay, so 0.04 divided by 2 equals, that's 0.02. All right, so let's write that. That's 10,000 times 1 plus 0.02 to the 2. All right, next thing we're going to do is we're going to do inside the parentheses, we're going to add the 1 plus 0.02. So I'm going to put an equal sign. 10,000, I'm just showing my works to make sure I don't lose anybody. 1 plus 0.02 is 1.02 to the 2. All right, next we have to do the 1.02 to the 2. All right, so I'm going to go to my calculator. I'm going to add 1 to it, so I have 1.02 there. And I'm going to do this button. I'm hovering over it so you see. I'm doing the X to the Y button just like I was doing the other day. To the 2, and that is 1.0404. Now, that's what this is. That is 1.0404. Now, since I already have that in my calculator, I'm just going to go ahead and take that and multiply it by the 10,000. So we're going to multiply it by 1,0,0,0,0, 10,000 equals. That is $10,404. All right, so my answer is, I'll do it in purple. My answer is, my A of 1 is $10,404. So you put $10,000 in your savings account. It earned 4% annual interest that was compounded semi-annually, which is twice a year. How much money would you have at the end of 1 year? That's it, $10,404. All right, the next question says, what if you had that same money in the bank, but it was compounded quarterly? Think about that for a minute. All right, I took a minute to erase it so we could kind of have a little bit of a clean slate. All right, so let's write our formula again. So we're going to do A of t equals the amount that I'm going to have at the end of however much time. Principal multiplied by 1 plus the rate over the number of times it's going to be compounded to the power of n times t. All right, so let's start with, what's our principal? Well, it's the same thing we just did, so it's 10,000. So let's write that. All right, well, what's our rate? Well, our rate's still the same thing. It's still 0.04. That didn't change. N is what changed. The number of times it's going to be compounded quarterly. How many quarters are in a dollar? 4. So that's 4 times a year. And we're still going to say the time is 1 year because they didn't say that changed. All right, so we're going to say A of 1 equals $10,000 times 1 plus the rate, which is 0.04, over n, which is 4, to the n, which is 4 times 1. Now, 4 times 1 is 4. So I'm just going to erase that times 1. You can't always do that, but we can for this one. So what we're going to do is we're going to try to put this all in our calculator in one clean sweep. But before we do that, we're going to break it down in pieces so we can check and see if our answer is correct. All right, the first thing I want you to do is you're going to do 0.04 divided by 4. All right, so we're going to clear our calculator and do 0.04 divided by 4. All right, that's 0.01. So that right there is 0.01. We're going to add that to the 1 that's already in front of it. So it's going to be 10,000 times 1.01 to the 4. Now I think we can put that, I like to do my exponents first because that's PEMDAS. Please excuse my dear Aunt Sally, Susie, whoever she is, because I know for sure it's going to be right. So we're not just going to write it all in exactly the way we see it. So I'm going to take the 1.01. I'm going to make sure that's in my calculator. So I'm going to add 1 to it. So now I have 1.01. And that was to the 4th power. So I'm going to hover over this little button that you're going to use, to the 4th power equals. So that's a pretty long number. I don't really want to write that one down. But let's go back. We did 1.01 to the 4. And so now we're going to times it or multiply it by the 10,000. So I'm going to go back to my calculator. I'm going to multiply it by 10,000 equals $10,406.04. Write that down. Help me remember that. All right, so A of 1 is $10,406.04. So I'm going to write the answer in a different color. So I'm going to say A of 1 equals, I'm just writing it again just to make sure you can see it and where you know that is the answer. Because it said, what if the interest is compounded quarterly? That means 4 times a year. So you would get more money than you would if it was only compounded semi-annually, because semi-annually you would get $10,404. Ooh, $2 more, right? $2.04 more. All right, let me erase my screen. All right, we're going to start back. I just want you to go to where it says notice, and I didn't want it to be so scattered. Notice that the more often interest is compounded, the more money you end up with. It would be reasonable to say that you would make more money if the interest were compounded monthly, and you would make even more money if it was compounded daily. All right, so what if we could just compound interest continuously? It's just always being done, and we can. And that's why we have the special variable E. That's when we need the variable E. Now, you know how we have the I for imaginary numbers? Okay. Well, we reserve the E to represent the natural number. Now, E is kind of like pi. You know how pi is 3.14, but it goes forever and never ends and never repeats? Well, E, it is a specific irrational number that never ends and never repeats. So E is approximately 2.7, and you could keep reading it. So I want to show you that E is 2.7. So go to your calculator. I'm going to go ahead and close mine out and open it back up so nothing's in there. And I want you to find the E. Okay, click on the E. Boom. What did we just say the E was? We said it was about 2.7. Just like pi is about 3.14. Well, E is approximately 2.7. And we know that. So I want you to do a couple of things with your calculator. We're going to just kind of not look at our notes for a minute. And you don't have to write this down. I just want you to play with your calculator. So don't go to your notes page. I want you to do E to the 6. And tell me, if you did 2.7 6 times, about what number would you get? Okay. So I'm going to go ahead and clear it out. And I'm going to do E. And then I'm going to hit this X to the Y. That means I'm putting it in exponent form. 6. And I'm going to press the equals button. If you did E to the 6, that's taking 2.7 and multiplying it by itself 6 times. You're going to get approximately 403. All right, let's try another one. Let's do E to the 0. Okay, let's go to your calculator. I didn't mean to close that on mine. Sorry about that. All right, we're going to do E. Hover over that button, X to the Y, and we're going to do it to the 0. And then press the equals button. 1, because remember, anything to the 0 is 1. All right, try this out. Let's do E to the 3. Remember, that's 2.7 times itself 3 times. Okay, we're going to clear it. E, hover over that button to the 3, equal sign, approximately 20. Think about it, 2.7 is almost 3. And if you did 3 to the 3, that's 3 times 3 times 3. Okay, it's not quite 27, but close, right? All right, let's do another one. We're just getting used to this E button. Do E to the 8. Clear it out. Do E. Hover over the button. Hit it. 8. Press the equal sign. E to the 8 is approximately 2,980. We would end up rounding it to 81. All right, let's see if we can do the E to a fraction. Let's do E to the 5 halves. And you're going to have to put it in parentheses like I did. All right, so clear it out. Do E. Hover over that button. Hit it. Do parentheses. And do 5 divided by 2. Close your parentheses. And hit the equals button. It should be approximately 12. Let me show you that again. Okay, we're going to do E. We're going to do the button X to the Y. We're going to do parentheses. 5 divided by 2. Close your parentheses. Press the equals button. It's approximately 12. All right, let's do one more. Let's see if we can do a negative in this computer calculator. We're going to do E to the negative 2 and see what it turns out to be. All right, we're going to clear it. We're going to hit E. We're going to do X to the Y. We're going to do parentheses. I'm going to hit this negative button. It negates it. Good. And I said I was going to do it to the 2. So I'm going to press the equal sign. Nope, that didn't work out right. That's not the right answer. So let's clear that. Let's try that again. Let's do E. I'm going to do parentheses. I'm going to hit the negative button. 2. Close parentheses equal. Nope. So let's see if we do E to the 2 negative. Let's see if that'll work. Yep, that's it. So this calculator's backwards. You have to put the 2 in and then the negative, because that's the right answer, 0.1353. All right, so we practiced enough with the E. All right, I erased my screen, so now that you're familiar with the E. So E comes about because while it seems like compounding interest continuously should be great for your savings account, at some point there's actually a limit to how much interest you can earn, since the total annual percentage rate is being divided into such teeny tiny pieces. All right, so here's another formula. Write this down. Even though it's written there, the more you write it, the more you remember it. A of T equals P times E, and the E is raised to the exponent of RT. Now, I call this the Pert formula. Okay, the Pert formula. So let's see. A is going to be the amount after whatever time period you're looking at. P is going to be the principal. The principal is always the initial amount that you're putting in the bank, or the initial amount that's sitting in the bank. R is the interest rate, whether it's a rate of growth or decay. And T is always the time in years. It's never in months. It's never in days. It's in years. All right, let's go to our first problem. Go ahead and write the formula again. A of T equals Pert. So capital P, little e, raised to the RT. All right, so for this problem, find the amount in a continuously compounded account after 3.5 years. Okay, that's going to be my T, right? 3.5 is going to be my t. If the principal is 3,900, okay, so my principal is going to be 3,900. And the annual interest rate is 2.8. So don't forget when you're doing rate, you have to take the decimal and move it 2 places to the left. So that's really going to be 0.028. All right, so we're going to put this in our formula. So we're going to say A of 3.5, because that's how long they want us to see how much is in the bank after 3.5 years and after the interest has been compounded continuously. All right, our principal is 3,900. Check. We write the E. We don't put 2.7 or anything. It's being raised to the power of R, which is 0.028 times, I'm going to put an X for times, okay, the T, which is 3.5. Now we're going to go ahead and put that right there in our calculator, okay? So I'm going to go ahead and write A of 3.5 equals 3,900 e to the, and then we're going to put whatever we find out. So we're going to go back to our calculator, okay, and we're going to put 0.028 times 3.5 equals, all right, we're going to write that down, 0.098. All right, so this is 0.098. All right, now, you always want to do exponents first. So we're going to plug in to the calculator the e to this power first. Now, when we plug it in, we're going to have to put those parentheses. Now, if you wanted to, you could have just plugged it in right here and put the parentheses there. You would have done this. You would have said e parentheses 0.028 times 3.5 close parentheses. So you could have done it then, okay? I'm just taking it in steps just to make sure I don't lose anybody. All right, so I'm going to take e to the parentheses 0.098, and then I'm going to times it by the 3,900 that's in front of it, okay, because you want to do your exponents first. All right, so let me go to my calculator. Let me clear. I'm going to do e. I'm going to hit x to the y. I'm going to do parentheses, and I'm going to do 0.098. 0.098. Close your parentheses and press the equals button. Now, times that number by $3,900. Okay, so write this down. $4,301.55. All right, so let's write this in a different color. It's our answer. A of 3.5 is $4,301.55. So that's how much would be in the bank. All right, this is our last question before your 3-day weekend. Tomorrow you can just play catch up on anything you need to play catch up on. All right, if you want to save $5,000, all right, they're telling me how much I'm going to save. So that right off the bat, they are telling me that A of T, they want to save $5,000 after a certain amount of time. You want to save $5,000 to go towards buying a car in 6 years. Okay, we even know the time. The time is going to be 6. How much money should you put into your account? Okay, so they're looking for the principal amount that earns 4.6% annual interest. Okay, that's going to be my rate. Drop the percent sign, take the decimal, move it 2 places to the left. So 0.046 compounded continuously. So that means we're using E. When it uses those words, compounded continuously, that's when you use the E. All right, so let's set up our problem. A of T equals PERT. Capital P, E to the RT. All right, now our A of T is $5,000. We know how much we want to save. We don't know what our principal is, so P stays as P. All right, E to the rate times the time. All right, the rate is 0.046 times the time, which is 6 years. All right, we're going to go ahead and plug that into our calculator. All right, let me clear this out. So we're going to do 0.046 times 6. Okay, 0.276. All right, so this is 5,000 equals P times E to the, I already lost it, 0.276. 0.276. Now think about it. We want to find the principal. So we need to isolate P. We need to get it by itself. So if P is being multiplied by E to the 0.276, then we're going to have to do the opposite of multiply, which is divide. So I'm going to have to divide this side by E to the 0.276. Whatever I do to the right, I got to do to the left. So I'm going to divide this side by E to the 0.276. And we know these are going to cancel. And we're going to get what P is once we plug that into the calculator. So make sure you have that. So 5,000 divided by E to the 0.276. Now remember, I could have kept the 0.046 times 6 and put it in the parentheses, just like I have that in the parentheses. Either way is fine. You're going to get the same answer. All right, clear it out. So 5,000 divided by E to the, I like to do parentheses because I don't trust calculators, 0.276 to the 0.276. Close your parentheses, press the equals button. $3,794.06. All right, so let's go write that. $3,794.06. That's how much that this person has got to put in the bank if they want to have $5,000 sitting in there in 6 years. Okay, that's the end of our lesson. Let's go ahead and go to, that light's really shining bright on me. Sorry about that. Turn it that way a little bit. To our pacing guide where it says 4-9. So today is April the 9th, and this was our 9th lesson. There's your homework. Homework page 448 to 450, problem numbers 28 through 31, 41, 44, 49 through 53. You have your mandatory upload where you're going to do the standardized test prep worksheet and you're going to upload it onto Focus. So tomorrow, you can just play catch up. You have any homework assignments you need to catch up on, you have any downloads you need to catch up on, go ahead and get that done. So Monday when we come back, you'll be ready for some more remote online learning. All right. See you later, guys. Thanks so much for everything. You are awesome. Happy Friday tomorrow.